regardless of whether somebody studies computer science or not these days, a lot of things are moving in a direction where people are writing software.
Hey, my name is Felix Tia. I'm the host of the Culture of Code. We invite experienced, successful tech industry leaders like software engineers, engineering managers, product managers to reveal exactly what they learn about growing and succeeding in the tech industry. In this episode, we have Abhishek, engineering manager of autonomous driving at Nvidia. So first of all, you mentioned to us that during your academic journey, you realized that you were drawn to software engineering through computational research. So tell us more about what is computational research and what drew you to it.
Yeah. So to answer your first question, so what is computational research? It's basically any kind of research for which you have to rely on some kind of either complicated or large scale computation, which is always implemented in some kind of software. So what that means is necessarily that for that kind of research, you have to rely on and often write a lot of your own software. And so one example of this would be somebody working on computational fluid dynamics. So there's a lot of those kinds of experiments that you can just simulate, which in one way is cheaper because you don't have to set up physical experiments. In another way, it's expensive because you need a lot of computational resources for it. But something like that relies on a lot of software being written. So similarly, what I was working on was this technique called light field imaging, which is essentially, you can say it's a computer vision technique, or sometimes what's also called the computational photography technique. But essentially what it is that you're taking images or video streams from multiple cameras, and then you're processing them using software to achieve certain unique capabilities. And so what I was doing as part of that was writing a lot of software to do all of that computation and processing. And then on top of that, additional software for analysis.
It almost sounds like a means to an end for your particular research. When did it kind of shift for you where you really kind of dove more into the software engineering side that maybe wasn't necessarily driven by as a need for you to do your computational research?
Yeah, I think, at some point I just sort of realized that one, I always liked writing software. I mean, and that probably goes back all the way to high school, but it just took me a long time to sort of really realize that and focus on that aspect more. And what I appreciated about that kind of research was that I did not have to set up physical experiments. And to me, that was simpler because I could control everything when it comes to software. With experiments, you're working with the real world, and there are certain things that you cannot control and things tend to go wrong. Now, of course, there are certain kinds of experiments that you can only run in real life. And so if somebody's working on that kind of research, right, that's the only option. And I think there's also a lot of people who don't really mind the messiness of the physical world. But partly because I enjoyed writing the software, which, as you said, was a means to an end. And also because I figured I could control things more and make progress that way is why I think I was kind of drawn to that more than working on research that required physical experiments.
And did you study mechanical engineering before transitioning into more the software, computer science and software engineering?
Yeah, I did. And actually my undergraduate and master's were pretty much completely mechanical engineering. The interesting thing is, though, and I've sort of mentioned this in a few other places, regardless of whether somebody studies computer science or not these days, a lot of things are moving in a direction where people are writing software. So what that means is you can be studying biology, and there's a subcategory in biology called computational biology. Or you can be studying mechanical engineering, and as I mentioned, working on let's say computational fluid dynamics or electrical engineering. There are aspects in all of these fields that require writing software. And the reason for that is because of software. Suddenly now all of these things are possible that weren't possible before. And software is still a means to an end, right? But it's just applied to different domains now. So despite the fact that I took mostly mechanical engineering courses, I was still exposed to software in various ways through some classes or through some projects and stuff, which I sort of, continue to enjoy throughout both like my undergraduate and my master's. And so in some way, transitioning over to doing more things that would typically be associated with computer science wasn't that big of a leap. I think a bigger leap was interviewing for tech companies. And it seems like there's a style in which that is done, which you are more exposed to if you study computer science, less exposed to if you don't. But otherwise, software is still software. So regardless of whether you're writing it as a computer science student or as a biology student, it's the same kind of foundation that you build.
Yeah, that sounds pretty exciting that there's basically software engineering is more pervasive than maybe people have known. What do you think about that in terms of like the opportunities, let's say career prospects for someone that might have traditionally had much more of maybe a narrow idea of what software engineering means? Like maybe you're building SaaS products or building consumer apps, but now you're talking about software playing a really critical role in a lot of these other fields that need people to write software, whether it be for research or maybe something more commercialized. But like, have you seen that actually play out or more in the actual job beyond research and into actual careers?
Yes, I think it has. I mean, it may be not obviously visible because generally, I think whatever's part of the popular conversation is driven by what's happening in the 90% of the cases. But I think maybe more than 10 years back, one of the founders at Andreessen Horowitz, which is a popular VC firm, had said that software is eating up the world. And actually, since then, it continues to eat up the world. More and more things are becoming software driven. And as you can also see, the tech industry has expanded into so many other domains. One example, I think maybe a role that exists today that didn't exist or didn't exist in a meaningful way about a decade back was that, especially at a company like Nvidia now, right? Because Nvidia focuses a lot on accelerated computing, which is sort of a generic term. So accelerated computing doesn't need to be just for graphics or machine learning. It can be for solving physics equations. And that's actually one of the things that some teams at Nvidia are working on. And they would want to hire people who have a background both in some amount of software engineering, but also the physics side of things. So they probably need to understand or have worked with Navier-Stokes equation or Maxwell's equation. There's like some 4 or 5 sort of fundamental equations that govern most kinds of physics out there. And I think that's something a lot of people who sort of fit that criteria, fit that eligibility or that background criteria, do not tend to come from computer science backgrounds. They'll often come from a physics background or chemical engineering or mechanical engineering background.
What do you think that means for like education, that when you are thinking about, let's say people that are listening that are in college, thinking about going to college or maybe going back to grad school, if there's this demand for what used to be 2 separate disciplines, right? Someone that graduates as a physics major or a comp sci major, you usually, I mean, there's obviously exceptions where people are graduating with like double majors, but for the most part, most people are not double majoring in these 2 areas. Do you see that changing and that being a requirement moving forward, or how should people think about how to prepare for that changing job situation?
Yeah, I think in a lot of ways it is changing, or you can say it has already changed, at least at some of the top schools. So regardless of department, schools will make sure that undergraduates going through different programs get exposed to some kind of coding skills. But I think the way people should think about this is not that, I think people have to get the notion out of their mind, which is that software is a computer science skill. I think software in our day and age is almost like everybody, at least in a technical field, should know math one can argue that depending on what you're working on, you should know different kinds of subjects within math or to different varying degrees of advanced levels. But software is sort of a generic skill that everybody should know. And part of the reason for that is because there's so many things you can do today using software that aren't restricted to things that would be associated with computer science. And so in that sense, I think, especially in technical fields or what are called STEM fields, I think everybody should know a minimum amount of software development skills. Now, keep in mind that when we say software engineering, that means something slightly different. And that's basically software development skills applied in a different way or in a different level of rigor. And that's partly because the way software companies view software engineering, right? It has to be done in a certain disciplined way because their product is the software, right? So, and their product shouldn't break and it should work and it should be reliable and robust, which requires a ton of extra work that, let's say, you wouldn't do or people generally don't do if they are writing software in graduate school. But nevertheless, right, the delta between those two things is just some best practices and some extra work required for, let's say, testing and such. But, people are still writing software in both cases, and just the ability to just write software, and you can put aside the testing and the best practices part. Just the ability to write software, I think, is a powerful skill that people in all STEM fields at least should be exposed to, and maybe even outside that, because it's just a useful tool for various things.
Yeah, and hearing you talk about this makes me think about I think the question that a lot of engineers have, especially when software engineers have, especially let's say they're mid-level engineers, where they're thinking about, should I specialize or should I be a general kind of like software engineer? What are your thoughts here? Like, what do you see as like the situation today about like what's more valuable and how that might change moving forward?
I don't know if I have a strong opinion on that one way or the other, because you can make a case for both being a generalist or specializing. Because at certain times, depending on what's going on in the industry. So for example, right now, or even starting maybe 4 or 5 years back, machine learning has been all the rage. Will it continue to be the rage for another 10, 15 years? Maybe, maybe not. So whenever there's something popular going on, which turns out to be more than hype, I think there is value in specializing. But at the same time, I would say probably the most valuable skill to have is to have the ability to kind of dive into things and specialize on demand. Because
let's talk about
lets
that.
Yeah.
I was gonna say, you mentioned that what you see as being very important is being able to align yourself with the most profitable industry of your time to kind of ride that wave as it goes up, to ride the wave as well. How do you know when it's more than hype? Because right now it's like, again, like you mentioned, machine learning, AI there's a lot of substance to it, but also with anything that's really popular, there's also a lot of hype. So how do you know when you're actually standing on solid ground and something worth investing your time into?
I think being associated with a profitable industry, I think you have to look at the industry as a whole. So I would say, machine learning or AI is a phenomenon within the tech industry. But the tech industry as a whole, it's pretty obvious that's the most profitable industry right now. And you can use some very rough metrics to evaluate that. You can just look at what are the top 10 most valuable S&P 500 companies. And right now it's mostly a bunch of tech companies. That wasn't the case 20, 30 years back. So in fact, not too long back, I think like ExxonMobil used to be the most valuable company. And right now I think it's Apple. And that's one of those industry shifts, right? Like the companies that are most valued in the stock market are valued that much because they're the most profitable. And at least I believe, and some people might disagree with this, but profitable companies they are capable of treating employees well. They are always getting into new things, new projects. So work tends to be more exciting. the future seems bright. So people are motivated because the company is doing well. So it's hard to be motivated in a company that's sort of is running into headwinds and is not doing well. So I would say people should associate with tech, not worry about that, if I want to be part of tech, then I have to be a software engineer. Because at the end of the day, all of these tech companies are businesses. They have all functions that typically all businesses have. So even if somebody is not an engineer, I think it's a good idea to be associated with tech now. Who knows, maybe 20 years from now, it would be predominantly space companies or something like that, something crazy.
Yeah, that'd be cool.
But
Cool to see.
that's what it is right now. Yeah. One could argue that space is also tech, but a different kind of tech.
Right. That makes sense. Given your perspective as like an engineering manager today, have you seen the successful transition from someone that, let's say, it's like a software engineer role on your team that decides to pursue another type of role in the tech industry? And what have you seen as like successful transitions from not hardcore, but very focused on software engineering beyond that track to transition to something else that's within the tech industry?
I think the most common one that you see is software engineers transitioning to product managers. And you can almost kind of generalize that to not product managers, if we just call them product people. And why I'm saying that is because let's say somebody works at a startup and maybe they're not called product manager there, but maybe the work they do is defining the product. Or somebody becomes a founder of a new company and they're doing a lot of sort of product definition work. I think that and that generally happens because people, realize that maybe they have a knack for it or they are interested in product definition work. And then they would be more valuable to the company as a result. Or at least that's how I think that, in my opinion, should be the reasoning. I've also heard people say, becoming a product manager is like sort of somehow otherwise desirable, which I don't necessarily agree with because it's not like product managers are compensated better than software engineers. It's just a different role in a similar way as like being an engineering manager is a different role than being an IC engineer. Some people also get into project management, and in my mind, I think that's also like a project management is one role, but there's people who are essentially focused on or driven by execution related topics. So which has less to do with product definition, but more like product's been defined. How do we execute this in an efficient way and get it out the door? So outside of core engineering, there's these functions in companies where there's execution work, or there's operations work, there's product definition work. And I think software engineers often have the required foundation to transition into those things. But of course, there's trade-offs, right? I think you want to become a product manager or you want to become an execution person if you enjoy that and you would do that well. And in that situation, I think the company will value that and reward that. But just for the sake of doing it probably doesn't make sense because, really good product managers, or for that matter, really good people in any kind of role are generally rare. Making a change like that is totally possible, often works, and I think is a great idea if somebody realizes that they have a knack for that or are more interested in that. And then they, as a result, will do a really good job in that role.
Yeah. And whether you transition in that way or go from an IC to an engineering manager or transition to a completely different niche within your industry, you mentioned how it's very valuable to be able to learn and be able to dive in like on demand. How do you recommend people kind of stay nimble and be able to dive in? And I guess what do you attribute to someone that is capable of being able to dive in on demand?
Yeah. So I'll be honest, I think that's a little bit tricky because that's like asking what is the sure shot way of finding and hiring the right people who will be flexible and be able to do whatever the company needs to do. And I think that's a hard question to answer. You ask 10 people, they'll give you 10 different answers. So I think if we put that part aside, which is what things do you associate with people like that? But if I was an engineer or as an engineer, there are things people can do in order to stay flexible. And I think some of that just comes through whatever they're doing as part of their day-to-day job. And some of that kind of they have to do on the side, maybe. But I think tech is a rapidly changing and evolving field. And so what that means is that often what is a valuable skill today is not a valuable skill 5 years from now. In fact, for example, there's a certain way people write software today. And I believe that people will write software 5 years from now in a completely different way, using all the new AI tools that will come out. And I think this is one of those times where people have to adapt. And if you're writing software the same old way 5 years from now, unless you're doing something really niche, I think people who write software with AI in the loop will just be much more productive. And I think that'll be more desirable as a skill. But I think generally it's important to keep up with the trends, keep learning about how things are changing and why, what are the new programming languages coming out and why, what are the new, I guess, emerging within the industry. One example of that could be machine learning. One example of that is robotics. I mean, there's some overlap between machine learning and robotics, but if you think about it, robotics is not a pure software engineering field, that is to say, what makes somebody successful in robotics is not having an understanding of what is a computer or like how things work at the low level in computer processing or in the memory and things like that. Those are all things that make somebody a good software engineer. But in a field like robotics, there's all these other skills that are valuable. Understanding geometry or algorithms that are associated with robotics or things like perception, planning, control, things like that, which in some ways they have almost nothing to do with software engineering, right? Software is just a way to express those algorithms in a machine. Means, right, that I think with all of these new things coming out, and maybe AR, VR might become a thing in the future, which also requires these other things. I think it's important to keep up and try to learn some of the things required for those subfields. And I think that allows people to jump into those things. Now, I also understand that sometimes this is sort of easier said than done. One might argue that, look, it's less important to keep up and learn, but it's more important to have like a really strong math background, which sort of makes you able to learn all of these new things easily. Or a physics background also, right? And I think there's a lot of truth to that. People who have spent time really understanding physics and math in some ways, in my experience, have that ability to pick up new things and generally understand it and then make progress. And that's more easily done while somebody is in school. So, for example, I think people should go out of their way and use electives and such to take courses, maybe in advanced physics or advanced mathematics, just to form that foundation. One example here is actually, I think there are computer science programs out there that don't expose people to advanced calculus, but somebody who studies mechanical engineering might get exposed to that more. But if you look at machine learning, I think having an understanding of advanced calculus is valuable. So I think people should, if they're in school, right, they should try to develop a strong physics and math background, not just focus on the things they're supposed to take for whatever their major is. And I think once people are in industry, figure out ways to stay up to date. Now, a lot of that also becomes easier if you're just interested in these things. But sometimes I think it's a function of if you get out there and learn more, then you tend to become more interested. The Bay Area especially is a great place for staying up to date with things like these. There's like all these community meetups that happen all the time for all kinds of new things, which are mostly free. So anybody can just show up, and you just look at people present some stuff or talk to people. And that's a good way to keep up with what the conversation is in the industry at that time. But going back to like on the hiring side, what kind of things I would look for. I would still look for that general strong background that I mentioned. So what that means is I don't specifically look for people who have studied computer science or who have taken certain courses. I will look for people who have a really solid understanding of math and physics. And as a result, what you see is that something like software engineering comes pretty easily to them. So, I mean, in fact, there are people in my team and in my larger org, a lot of people actually, I mean, including me, you can argue, who don't come from computer science programs. And they have a physics PhD or something else, or mechanical engineering, electrical. And I think generally just speaking, they're smart people, right? And that's what makes them smart people. And they have studied and they have the foundational background to be flexible and to pick up machine learning and learn about it, pick up robotics and learn about it. Because at the end of the day, all of these things are, logic, math, physics. So, yeah.
You kind of alluded to this earlier about how even though you have all of this strong background and the knowledge to do the job, you alluded to the fact that the big kind of gates or hurdle to get over is the interview process, which for a lot of companies don't necessarily test on the things that you might have learned in school, especially if you didn't come from like a track that had a heavy emphasis on, let's say, like data structures and algorithms, and you have to do those kind of tests to get the job in the first place. Do you see that changing in the future, or do you see that changing now where there are different ways of interviews or different emphasis or different things that are being emphasized to, I guess, bring into the fold more people that might not have had the coursework that would have helped them with the interview, but would be super valuable because of the coursework, because of their experience on the job itself?
I actually don't know if that is changing or will change in any significant way. And I think part of the reason for that is the things, at least the way I see it, and I know a lot of people will agree with this. It's really the base skills that matter. Those are the hard ones to learn. So for example, being comfortable with writing software and having that sort of fluency is a hard thing. That's not something you can develop in a month. But learning about certain algorithms is considerably easier. So if somebody has written code, but has not, let's say, taken a formal course in algorithms or data structures, it's much easier for them to just, look at a bunch of stuff online these days and then just learn, oh yeah, there's these common data structures and some of these algorithms. But I think companies still will need a systematic way to interview. So what that means is, right, in a good interview process, you want to check for sort of algorithmic or conceptual knowledge and math and physics background, things like that. But then you also want to check for comfort with writing software. But that comfort with writing software can't just be, ask somebody some random question every interview. And I think focusing on certain algorithms adds some structure. Now, I'm not saying, I think it is possible for people to come up with structure that doesn't require formal knowledge of algorithms and things like that. But you're still asking people to solve some problems. And oftentimes, most problems require some kind of base algorithm or combination of different ones. And sometimes people will implement what is traditionally a studied algorithm, even though they don't have a formal background, because, logically, that's just where they arise. I think what is not going to change is the fact that people will interview you and evaluate comfort with coding. Now, they may not ask specifically for implementation of certain algorithms. They may just generically say, hey, this is a puzzle or a problem that we want to solve, and we want to see how you approach it. And so that, I think, will stay. Although I think it'll be interesting how some of this evolves in the age of AI copilots and stuff. So that part isn't too obvious to me. But yeah, I think so the summary, I think, is right that there's a little bit of adaptation people have to go through if they're coming from a non-computer science background. But typically what I've seen is that that's not that difficult to do if they have the base knowledge and experience, which again is just they have written software, they have a math and physics understanding. The learning the algorithms part is easy.
And for you as a manager, I wonder if some of the common myths that you hear people have about management is that one, managers being paid more, and two, the confusion between growing as like an IC and in their mind, the inevitable path to now becoming a manager after you reach some level of growth. Do you see that these kind of held beliefs being harmful to like a team or to an individual?
Yeah, I think in some ways they are. So, for example, just to address being paid more part, again, I'm saying this based on the understanding of things that I have. I'm not speaking based off of some stats, but generally speaking, managers at low levels, basically the kind of manager roles people would transition into at early to mid-career stage levels. The delta in compensation between equivalent IC levels and manager levels is not really that much. So there's always a band in which people get paid, right? There's a distribution. At the same level, people will get paid between so much and so much. I think those bands tend to be similar. Once you get to really senior manager positions, I think there is a large delta. But then at that point, right, you're doing a very different job. So like a VP in a company who runs a business unit, which is almost like saying what a CEO does at a company of a similar size as that org is different from an engineering manager delivering things with a team of 10 people. So I think at really senior levels, there is a delta, but at early levels, there isn't. I think one thing that companies might face some challenges with is that a lot of people have the desire to become managers because there's some notion of prestige associated with that. And I think there definitely are disadvantages of being okay with that and then making a lot of people managers. Because at the end of the day, I believe that a company has to solve the problem of what is the least number of managers we need, not managers we should have or somehow based on how many people want to be managers. What is the least number of managers we need in order to make sure that the company is able to execute and make progress smoothly? And I think that number is very different from the number you would arrive at if you ask people, hey, in order to be happy, do you want to be a manager? So I think the prestige aspect is a tricky one because sometimes that's unrelated to compensation. But maybe that kind of runs into a personality fit issue where if somebody really wants to be a manager, regardless of whether that role pays more or less even, let's say, just for the sake of an example. And if the company doesn't need managers, that's just a personality fit issue. But if it's more because people think that, oh, they should become managers because they need to get paid more, I think the company needs to do a better job at explaining that to people that that's actually not true. And that way, right, the company stays sort of lean and productive, which is a good thing.
Yeah, that's an interesting thought about how that it's not like a natural progression to just become a engineering manager, especially if you're coming at it, especially as an IC that sees it as like a obvious next step for the wrong reasons. So it makes a lot of sense how some companies can be very bloated and have a lot of management when it could be better serving the company if a lot of these very high performing ICs continue down that track and see that there's still value in them continue on the track that they're on.
Yeah. And another myth is that engineering managers are just ICs who have now people reporting to them. That is also not true. The role of a manager is very different and it serves a unique purpose where you have to pay more attention to things like resource allocation, keeping the team motivated, hiring, retention, focusing on growth of employees, finding roles for them that will let them grow or they will find interesting and stay motivated in and things like that. And this stuff is not what ICs do at all. In fact, there's a lot of people who would not enjoy worrying about these kind of things. And I think because of that, sometimes what also happens is that people become managers because, I don't know, it seems like the right thing to do. And then find out that there's all this stuff they need to do now, which they don't really like doing. So I think maybe just companies should, if companies do a good job explaining that, hey, it's a different role, after all of those main priorities that you have, your team's doing well, people are motivated, you're hiring well, and everybody understands what exactly needs to be done and why. If you have time left over, yeah, you can do IC work. And if you're interested in that, but it can't be the other way around where you prioritize IC work, but then people in your team like don't understand what needs to be done and why. They don't feel like somebody's listening to them about their growth and things like that. So I think good companies do a pretty good job at making sure that doesn't happen, where people become managers and don't like what they're doing, and as a result, don't really do a good job. Unfortunately, I think that happens more often than it should.
That's a very good point about how this kind of communication needs to be much clearer from other companies. So yeah, really appreciate your perspective here. I think, again, a lot of people see this as a natural progression and the obvious next thing to do, but it's really a very different job, as you have made clear. There's a very different job, very different skill set, and it's not just almost another thing to do on top of your regular job. It's very different. So really appreciate you sharing all of that. Thank you so much for your time and your perspective. I think you have a very unique perspective about how the industry is changing, can change, and that there are this idea of software eating the world is not just about more software being created, but then software actually being used to help power a lot of existing industries and a lot of things that already exist. So I appreciate you coming on and sharing that perspective. Thank you so much for your time today, Abhishek, engineering manager of autonomous driving at Nvidia. And thank you so much for coming on and sharing your experience and your advice with us.
Yeah, thank you for having me.
And that's all the time we have for this episode. Come join us next time on the Culture of Code. Again, my name is Felix Tia. Take care.